Welcome to This Explainer. Today, we are transforming an incredible, wide-ranging conversation into a really structured journey. We're going to decode the wild, near-fatal origins of Nvidia, unpack the actual mechanics behind the modern AI boom, and explore how a single company completely reshaped the future of human computing. We've distilled hours of fascinating insights from the source material right here, so you can clearly see the exact roadmap of the AI revolution.
All right, let's just dive right into this. You'd think that running a multi-trillion-dollar tech empire, one that essentially powers the future, would let you sleep pretty soundly at night, right? Well, not for Nvidia CEO Jensen Huang. He actually wakes up every single morning with the anxiety that he is just 30 days away from going out of business. It's this completely relentless fear of failure, rather than just a hunger for success, that keeps him working 7 days a week. And as we're going to see, that paranoid survival instinct is exactly what birthed the AI era. To really wrap our heads around this massive topic, we're going to hit 5 key areas: 30 days from bankruptcy, the big bang of AI, understanding the AI machine, the global tech race, and finally, the American dream. Let's get to it. Starting off with Section 1, 30 days from bankruptcy. Let's look at Nvidia's origins. Picture this. It's 1993, and Nvidia starts out with a fundamentally flawed architecture. I mean, they were doing 3D graphics completely backwards compared to the rest of the industry. By 1995, they were completely out of money. So, in a desperate move, Juan goes to Sega, their biggest partner, admits Nvidia's tech was a failure, advises them to find another partner, and then actually asks Sega to convert their final $5 million contract payment into an investment anyway, just to keep Nvidia afloat. Miraculously, Sega said yes. Then, running on absolute fumes, Nvidia spends half of that remaining money on a discontinued hardware emulator just to test their new chip design. They went straight to production with a tiny foundry called TSMC without ever physically testing the silicon. It was a massive, completely blind bet that somehow saved the company. Moving right along to Section 2, the big bang of AI, how they accidentally catalyzed a revolution.
So you might be wondering, what's the actual difference in the hardware here? Well, think of normal computer brains, CPUs, as thinking in a straight line. They do step 1, then step 2, then step 3. But to render a 3D video game, you can't just calculate one pixel at a time, you have to calculate the entire screen all at once. So Nvidia built GPUs, graphics processing units, to process thousands of tasks simultaneously in parallel. They essentially built a supercomputer just for gamers.
And that massive parallel processing power, that laid the groundwork for 2012, which was literally the big bang of modern AI. Researchers up in Toronto were trying to teach computers how to recognize images. They realized that the complex, simultaneous math required for neural networks was exactly the same kind of math NVIDIA was using to render video games. So using just 2 off-the-shelf consumer gaming graphics cards, they created AlexNet, shattering decades of computer vision records almost overnight.
When Nvidia saw this flash of brilliance, they went all in. Instead of just focusing on gamers, they bet the entire farm on AI. They spent billions developing the DGX-1, which was a supercomputer specifically designed for deep learning. It cost a staggering $300,000. And when Huang announced it, nobody bought it. Literally nobody understood it, except for Elon Musk. Huang hand-delivered the very first unit to Musk and a tiny group of researchers sitting in a small room in San Francisco back in 2016. That little nonprofit startup, they were called OpenAI.
Which brings us to Section 3, understanding the AI machine and how deep learning actually works. The source material highlights a really beautiful definition from Huang. He calls AI a universal function approximator. Historically, humans had to hard code the rules. We wrote the software recipes line by line. But with deep learning, you don't write the recipe. You give the computer a massive switchboard. You hand it the raw ingredients as the input, and you show it a picture of the final baked cake as the output. The AI literally figures out the complex math in between all on its own. So deep learning basically happens in 3 steps. First, you input the data, say a massive amount of pixels representing a cat. Second, that giant switchboard of math takes a totally random swing at guessing what the image is. And spoiler alert, it usually fails at first. But third is the magic. You backpropagate the correct answer. You tell the system, no, that was a cat. And the system automatically adjusts millions of tiny little dials inside itself. You do this billions of times, and the machine learns. And guys, this is happening at hyper speed. Huang actually jokes that Nvidia's accelerated computing is like Moore's law on energy drinks. Over the last decade, computing performance for these specific tasks hasn't just doubled, it has improved by 100,000 times. This means the cost and, crucially, the energy required to do AI tasks is shrinking exponentially. Soon, AI is going to be running constantly in the background of our lives simply because the energy drain will be completely minuscule.
All right, Section 4, the global technology race. Let's talk about the physical infrastructure for AI. AI isn't just software floating in the cloud anymore, it's deeply tied to the physical world. From a strictly logistical standpoint, the source material notes that national security demands we localize chip manufacturing here at home. Furthermore, building these massive AI supercomputer factories requires immense amounts of electricity. The sources emphasize that pro-growth energy policies, sometimes literally phrased as drill baby drill, are cited by industry leaders as vital logistical necessities to ensure the power grid can actually support this industrial reawakening without completely crashing. It's a race for physical infrastructure just as much as digital code. But all this rapid global industrialization begs a massive question, and it's one that causes some very understandable fear. As this technology becomes everywhere, is it going to entirely replace the human worker? Take radiology, for example. When AI was introduced there, everyone predicted the job would just vanish. Instead, AI took over the tedious task of reading the pixels, which meant hospitals could process way more scans. And because they processed more scans, they actually needed to hire more radiologists to handle the crucial human element, diagnosing the disease and talking to the patients. It's the same with driving. If a car drives itself, the chauffeur's job might shift toward personal protection or high-end customer service. The task itself gets automated, absolutely, but the human purpose adapts. Then, of course, beyond jobs, you've got that ultimate sci-fi fear dominating the headlines. What happens if this universal approximator actually achieves sentience, decides it no longer needs humans, and becomes a literal doomsday threat?
Well, Huang firmly dismisses the whole Hollywood Terminator scenario. He argues that AI won't exist in a vacuum as one singular, all-powerful rogue machine. Instead, he compares it to modern cybersecurity. If there is a rogue or a dangerous AI out there, we're not going to be fighting it with sticks and stones. We will have millions of our own super smart, highly capable AI agents cooperating across the globe to monitor, patch, and defend against those threats in real time. The defense scales at the exact same pace as the offense. And that leads us to our final section. Section 5, the American Dream. Let's look at Jensen's personal journey. Long before he was a tech titan handing over supercomputers to billionaires, Jensen Huang was just a kid caught up in global turbulence. Born in Taiwan and living in Thailand, his parents sent him and his brother to the US to escape political unrest. At just 9 years old, he ended up at a tough boarding school in rural Kentucky. He was the youngest kid there, tasked with cleaning the dorm toilets, sharing a room with a 17-year-old who was recovering from a knife fight. His parents later arrived in America with nothing but their suitcases, fighting for their piece of the American dream. And there's this deep, almost poetic irony here. Before he ushered in this era of instant global computing, the pioneer of the AI age stayed connected to his parents by simply speaking into a cheap cassette tape, dropping it in the mail across the globe, and waiting weeks for them to record their voices over it and send it back. It was a massive struggle, for sure, but it forged an unparalleled resilience. Which really brings us to our final thought. As we stand on the absolute brink of an era where machines can approximate almost any function, read any scan, and maybe one day drive any car, the technology itself is no longer the bottleneck. The real question is, how will we use this immense power to define our own human purpose? Will we use it just to automate our tasks, or will we use it to elevate our humanity? Thanks for walking through this explainer with me. Keep learning, and I'll catch you on the next one.